We've got year 11 homework 4 here. It starts off with the questions about ions and ionic bonding. First off, when sodium reacts with oxygen, sodium oxide is formed. It's made up of positive and negative ions. What charge does sodium ions have and how are they formed? Well, remember to start with an ion. That's a charged atom or group of atoms. Charged atom or group of atoms. Now, how does an atom become charged? Well, the protons are positively charged, they live in the nucleus, they never change. An atom cannot gain or lose protons. The number of protons give the atom its identity, and that is fixed, it does not change. Neutrons are neutral, also in the nucleus, but electrons, they're negatively charged, and they surround the nucleus, and they are in shells. And they can be gained or lost, and that's how ions are formed. Because electrons are negative, if it loses an electron, it ends up positively charged. If it gains an electron, ends up negatively charged. Now, to know whether something is positive or negative, you can work it out like that. Yes, you could also look at the periodic table. Periodic table here, there is a metal, non-metal dividing line. It's invisible on your periodic table, but it's there. I've just traced it down. So basically it starts here, okay, and then it steps down this group here, like so. Okay, comes here. So if anything's on the left of it, there, it's a metal, and that would be positively charged. Okay, so they end up positive charge, say, lose electrons. And if it's this side, the non-metal side, they will gain electrons. They'll end up negatively charged. So non-metals are negative, metals are positive. So charge on sodium ions. Again, I'm not going to tell you sodium. You can find sodium on the periodic table and work it out. I'll do magnesium for you. So what's the charge on the magnesium? Well, it's a metal, so it's in a positive. But also, more than that, if we look at the group number of the periodic table, magnesium is in group 2. That tells us it's got 2 electrons on its outer shell. So it's going to lose 2 electrons, so it would be Mg2+. So if that question there said magnesium and not sodium, okay, the answer would be Mg2+, and the answer would be lose 2 electrons. Okay, but the question doesn't say magnesium, it says sodium, so you need to figure it out. Likewise, what charge do oxide ions have? Well, you need to find oxygen on the periodic table and work out whether it's positive or negative. And then the group number will tell us how many. So I'll do chlorine. Okay, chlorine's in group 7 of the periodic table, so it's going to form an ion by gaining 1 electron, because of course these atoms gain or lose electrons to get a full outer shell. So chlorine's got 7 electrons in the outer shell. We know that's because it's in group 7. Therefore, to fill its outer shell, which would take it to 8 electrons, it needs to gain an electron. So a single negative charge for everything in group 7. 2 negative charges for everything in group 6, because they need to gain 2 electrons. So sulfur, for example, needs to gain 2 electrons to get its full outer shell. Okay, so that will be 2 minus. Nitrogen here in group 5, 5 electrons in the outer shell, that would be 3 to take it to 8 to fill the outer shell. So that would be 3 minus. So, recap, 1 minus, 2 minus, 3 minus. And then for the other way, 1 plus, 2 plus, 3 plus. Okay, so let's say it was chlorine I was doing here, not oxygen. Chlorine, chlorine would be negative, and it would be gain 1 electron, because chlorine is in group 7. How are ions held together in sodium oxide? Well, let's say I'm doing magnesium chloride, okay? And we've got Mg2+ ions and Cl- ions. They're held together by electrostatic forces of attraction. By electrostatic forces of attraction. If that's a bit of a complex phrase for you, okay, let's say it a bit more simply. The opposite charges attract. Opposites attract. True in life, love, and in chemistry. Okay, opposite charges attract. Name this type of bonding. Well, it's formed from ions, so it's ionic bonding. Okay, so chlorine also forms a gaseous compound with oxygen, with the formula Cl2O. Explain or show by means of a diagram how these 2 elements bond to form chlorine oxide, and the name of the type of the bonding used. Okay, so to identify the type of bonding, okay, we go back to the periodic table, and we need to know where that metal-non-metal dividing line is. If the type of bonding involves a metal and a non-metal, it is ionic. So go back to magnesium chloride. Magnesium was there, chlorine is there. That's ionic, a metal and a non-metal. If the elements are both non-metals, it is covalent. Okay. So, for example, water, hydrogen oxide, H2O. Hydrogen is a non-metal, oxygen is a non-metal. That's covalent bonding. Okay, so I'm going to do this question assuming it's water, not chlorine oxide. You have to do chlorine oxide, I'm doing water. Okay, so water forms a liquid compound, or hydrogen forms a liquid compound with oxygen, with the formula H2O. Explain or show by means of a diagram how these two elements bond together. Well, they bond covalently because they're both non-metals. You need to decide whether chlorine and oxygen are metals and non-metals. Use the periodic table. A covalent bond, definition, is a shared pair of electrons. Now with covalent bonding, we do dot and cross diagrams. So I'm doing H2O. So if I look at the periodic table, okay, I see oxygen has got an atomic number of 8. Okay, oxygen's got an atomic number of 8, so I'm going to do a dot for the nucleus, 2 electrons on the first shell and 6 on the second shell. Now looking at this, oxygen needs 2 electrons to complete its outer shell. Therefore, it's going to form 2 covalent bonds. Each covalent bond is a shared pair of electrons. It's going to form it's going to be 2 bonds, one with a shared pair of electrons in each. So 2 shared pairs of electrons in total. So it's bonding with hydrogen. Look at the periodic table again for the atomic number of hydrogen. Hydrogen's got an atomic number of 1. Okay, so it's got 1 electron. So I need a dot for the nucleus, and I'm going to put one of those hydrogens over one of those unpaired electrons on the outside of oxygen. Now I do a dot and cross diagram here, so I show the hydrogen's electron as a dot. Now they're obviously both electrons, and an electron is identical, but by doing a dot and cross, it allows us to see where they've originated from. So looking at this oxygen now, it's now got 1, 2, 3, 4, 5, 6, 7 electrons in its outer shell, but we've got another hydrogen to go. So the other hydrogen has to go over that unpaired electron on the outside. So now I've got my 2 shared pairs of electrons. Oxygen has got 8 electrons in its outer shell, and hydrogen has got 1, 2 electrons in its outer shell. So that's a covalent bond. Next question, explain why the bonding diagram in sodium oxide produces a solid with a high melting point. Okay, so that's back to this, this ionic example to start with. So the question is asking you why ionically bonded substances have high melting points. Well, the answer is, of course, let's go back to magnesium chloride. We've got lots of these magnesium ions and lots of these chloride ions. Okay, can you all see that? And we've got, so there's not just 2 of them or 4 of them, there's billions of them. And every positively charged ion attracts every negatively charged ion, regardless of whether they gave its electrons to each other. If it's positively charged, it attracts negative charges. Okay, so we end up with billions of these ions all strongly attracted together. So you need to, it then takes a lot of energy to separate them. Okay, next question, so you can write that something like that there. Down here, explain why chlorine oxide is a gas at room temperature. Well, a moment ago, let's use carbon dioxide as an example. Carbon dioxide is covalent. There's a carbon dioxide molecule, CO2 molecule. Okay, now that bond there is incredibly strong. But here's another carbon dioxide molecule, okay? And those bonds in there are incredibly strong, but there is nothing between these molecules. The molecules themselves are not attracted. There's weak forces of attraction between the molecules, okay? So with ionic, there was strong forces of attraction between oppositely charged ions. So they had a high melting point. Ionic, high melting point. Strong forces of attraction between the positive ions and the negative ions. Here, there is massively strong covalent bonds in this molecule, but we're not interested in those. We're interested in what's between these molecules. Here's another carbon dioxide molecule. Again, very, very strong bonds inside the molecule, but there's nothing between the molecule. So to separate these molecules requires very, very little energy. And here, you know, think about it. This pen is quite strong. I can't really break it. I'm trying to break it. I could if I wanted to, I suppose, but I don't want to. But it would take quite a bit of force, quite a bit of energy. Here's a calculator. This is quite strong as well. I don't really want to break that, but if I wanted to, I'd have to put quite a bit of energy into it. But if I just want to separate the calculator from the pen, that's ridiculously easy. Because this pen is not charged, and this calculator is not charged, so they just separate. And that's what we've got here in covalent, simple molecular covalent bonding. Okay? So the unit themselves is strong, but there's nothing holding the different molecules together. You need to write something about that there. If you are writing, the covalent bonds in chlorine oxide are weak, that's wrong. Let me just repeat that. These covalent bonds in the molecule are very strong. What is weak is the forces of attraction between the molecules. There's a difference. I hope you can see the difference. There's a bond in the molecule, and the forces of attraction between the molecules are different. Next question. One of these compounds, sodium oxide or chlorine oxide, will conduct electricity under certain circumstances. Which of these will conduct? State the conditions necessary and explain why it does conduct electricity. To do this, you have to remember what a current of electricity is. A current of electricity is a flow of charged particles. A flow of charged particles. Okay, now those charged particles can either be electrons or ions. Ions are charged atoms. Okay, so if there's no free electrons and the charged ions cannot move, it will not conduct. So let's come back down to carbon dioxide for a moment. These bonds are formed by sharing electrons. Okay, those bonds are formed by sharing electrons. If they share electrons, there is no charge. Okay? Ions were charged because electrons went from one atom to another. There's no electrons being donated and accepted. Go back to this diagram of covalent bonding. Look, they're sharing. This hydrogen has not lost its electron. Okay? It's sharing it with an oxygen. So although it's lost a little bit, I suppose, because it's given it to the oxygen, it's gained a little bit from the oxygen as well. So overall, there is no charge on covalent molecules. Simple molecules are not charged, okay? If you go to A-level, they will expand on that. But for GCSE, simple molecules are not charged. Okay, so covalent will never conduct. Okay, covalent do not conduct. Well, they conduct poorly. Covalent do not conduct, or let's say covalent conduct poorly. Okay, why? Molecules are not charged. Molecules are not charged. Right. Ionic, though. Ionic substances are made of ions, but they won't conduct if the ionic substance is solid because the ions cannot move. Remember, a current of electricity is a flow of charge. If it's a solid, the ions can't flow, they can't move. So they won't conduct if it's solid. But if it's a liquid, then oh yes, the ions can move. Ionic will conduct in the liquid state, okay, because the ions can move. And that'll be really obvious then who's done their homework, won't it? Because I've answered that one for you. Okay, everybody can watch that if they are bothering to do the homework. It'll be a really good test. What are the products of electrolysis of sodium chloride aqueous? Okay, again, tough subject. Going back to electrolysis from year 10, I'm not going to do sodium chloride aqueous. Let's think. I'll do copper sulfate aqueous. What will be the products of electrolysis of that? Well, all these substances are ionic, so they will conduct in the liquid state. The easiest way to get them into the liquid state is make them into an aqueous solution. And into that solution, we put that solution into a beaker. So that in this beaker here, we have got copper ions, Cu2+, sulfate ions, SO4 2-, and of course it's a solution of, in other words, dissolved in water. So there's going to be hydrogen ions as well and hydroxide ions. There's 4 ions in that beaker, and there's 4 ions in this beaker as well of sodium chloride aqueous. Only 2 can be produced. Only 1 goes to the anode. And 1 goes to the cathode. Cathode negative electrode, anode positive electrode. Okay, so the negative ions are attracted to the positive electrode. Okay, so we've got hydroxide ions and sulfate ions. Only 1 goes there and is produced. Okay, now the rule is as follows. If the negative ion, the anion, is a halogen, a halide ion, what I mean by that is, does it belong to the halogen group? So if the anion is a fluoride, a chloride, a bromide, or an iodide, then that substance is given off. You'd get, if you start with fluoride, you'd get fluorine gas. If you start with chloride, you'd get chlorine gas. If you start with bromide, you get bromine gas. If you start with iodide, you get iodine produced. Okay? So if the substance is a halide, that is given off. That is produced at the anode. If you do not start with that, then the hydroxide ion wins. So at the anode, the hydroxide ion turns into oxygen and water and 4 electrons. And balancing that equation out, there's our half equation for that if we start with copper sulfate. So I've done that for copper sulfate. I'm doing it for copper sulfate. That is not the answer. Okay, well, it might be the answer. You'd have to work it out. It's not the answer for sodium chloride. Right, now, next one. The cations. We've got the hydrogen ion and the copper ion. The cations are the positive ions. The cations go to the cathode. Okay, so only one can be produced. Is it hydrogen or is it copper? Well, to answer this is about reactivity. So you do need to, you've probably given a reactivity series, but basically we've got things like potassium at the top, sodium, magnesium. Okay, now carbon is the, sorry, not carbon. Carbon is in there as well, but let's not worry too much about that. Let's have iron, let's have hydrogen in there, okay, and copper and silver. Now, hydrogen is the important one because we are competing with hydrogen here. Now, if the metal is more reactive than hydrogen, then the hydrogen is produced. If the metal is less reactive than the hydrogen, okay, if the metal is less reactive than the hydrogen, then the metal is produced. So most reactive is at the top, least reactive is at the bottom. Okay, now what we can see here in my example, copper sulfate, copper is beneath hydrogen, so copper will be produced. So the copper ions go there and turn into copper solid. I'll do a half equation for that as well. Okay, and there's that. So we've got half equations. I've written those there. Let's write down here again. So the cathode was the copper Cu2 plus 2E minus makes copper, and the hydroxide ions I said were produced and were reacted and produced oxygen and water and 4 electrons. Right, so they are my half equations for copper sulfate. You're doing it for sodium chloride, you will need different half equations. Okay, but for the cathode, it's about where it is in the reactivity series. If it's more reactive than the hydrogen is produced and the hydrogen goes into that half equation. If it's less reactive, the metal goes into that. For the anode, if it's a halogen, okay, the halogen is produced. If not, the hydroxide ion wins. Okay, that's a difficult question, so good luck with that.